Hi, welcome to the fun probability problem solving sessions. And today we're going to work the probability problem we're going to work is about the single variable transformation. So we have two pretty easy problems here to solve. So first one we talk about let x is a continuous random variable. So x have the following given PDF. So for example, the part A, the x is uniform from 0 to 1. And part B is here, the x is uniform from negative pi over 2 to pi. Then you have another variable y is defined in the different function. And now we are trying to find the PDF of the y's here. Okay, so now let's go ahead to our whiteboard and let's get started. Okay, before we start, let's do a pretty quick review. So this type of the problems here is very, very similar like when you learn in the calculus. When you were in the calculus class, this is very similar, try to find the, kind of like the U sub, okay? So now, we have a two-way we can, approach this type of the problems here. All right. So some people like one way and other like another. So the first ones here is you approach from the PDF. So you work from the PDF. Then the second part here, you can approach from the CDF file. Okay, so this is you can just directly work on the PDF, and then the second part here you can approach from the CDF, right? So after you find the CDF, then we know the derivative of the CDF will be the PDF. So either way is here. So let me just try to write down the formula we're going to use, and so the things we need to be careful is here. So let's see here for the given f of x has a PDF. Let's say here the f of x, so this is the f of x functions here. Then I have a new function is y is defined as the ux. Like I said, it's very similar like we talk about in kind of like the u sub here. All right. So now if y equal to the ux here, then you can find the inverse function. So you can say x equal to like some type of the function like y. I like to use the wy here. Okay, so then I can say the dx dy will just be equal to the y prime y here. Okay, so now after you do this transformation, then I can find a new function gy will just be equal to you substitute what is your x, right? X is because the wy is back to the x functions here, right? So the gy will just be the f of the wy. And remember in the U sub, you always have the du things. So in here, we do is the absolute value. This is what we call the Jacobians, right? So this is the f w prime y. The reason why I need to have the absolute value because I know the PDF cannot be negatives, right? Okay, so this is you can approach the problem from the PDF point, right? Or you can approach from the problem from the CDF. So what is the approach from the CDF point? So you can say still x has a PDF of f of x here, right? Okay, so now y still is a function of x. So from the CDF, so you can say okay, I use a capital GY is the CDF of y. So you can say this one's here really is your integrator from the domains, right? So I put the negative infinity as general domain. And to, let me put it in here, maybe use the definition better. So this will be the y less than equal to y's, right? All right. So then you can put the probability here. The UX is less than equal to Y. Then you still do the inverse functions. So you will say X is less than equal to WY. See here. Okay. And so now in here, because this is X less than WY, so then these ones here you can put into the integrations, and this is the, from the, I put a negative infinity as the general domains here. So this is WY, all right? And then you integrate the f of x dx. And after you get the gy, then you can get the the CDF of y, and then the lowercase gy will just be, you take the derivative of the CDFs here. So like I said, you can have the, either way, some people prefer to approach from PDF, some people approach from CDFs here. Okay, so the third thing is we need to be careful about these transformations, right? So it's just like we do in the U sub in the calculus. You need to redo the up and the lower boundaries, when you use subs here, right? So when the y equal to the ux here, right? So if x is from the A to B, all right, so then, okay, so then you need to, so then don't forget, you need to find what? You need to find the interval or the domain for y here. Those are the three things. If you be careful, then I think you will be fine. So a lot of the time the student forget to to find the to readjust the intervals here. Okay, let's take a look at our first problem here. So like the first problem say x is a uniform distribution, right? Okay, so x is part A is here. X is a uniform distribution. So I said y. Okay, so here. Okay, so x is a uniform 0, 1. So I know that I'll be able to write down the PDF. So I know the f of x is just equal to 1, and the x is from 0 to 1 here, right? And then it defined y is equal to the negative log x. So I will say negative y equal to the log x. So the x equal to what? X equal to e to the negative y here. Okay, so in here, some people, if you're very specific, they say, oh, this is not a natural log because this should be the, the common log because there's no base here. So yeah, if you want, it really doesn't matter. It's just the differences of a constant. So in here, most of the book, when we see log, we treat it as natural log. Like I say, if you think this is base 10, it's fine, okay? Okay, so now in here, I finally, so this is my wy, right? Like a while ago. So now I will say dx dy is equal to what? Dx dy is equal to negative e to the negative y. Okay, so this is my y prime. W prime y here. So now I use my transformation theory I put on the previous page. Gy will just be the x you put into the, the PDF, but this is a constant, so it's 1 times the absolute value of the wy. So this will be e to the negative y here. Okay, so this is my PDF here, but remember I mentioned you always need to find the domain. If you just write this, it's not complete here, all right? So now you say the y, okay, so the y, equal to the negative log x here. So you know when the x is equal to 0, log x will go into the negative infinity. So then the negative will give you the positive infinity. So when the x is equal to 1, the log 1 is equal to 0. So it will be 0. So I know my y is from where to where? My y is from 0 to what? Infinities here. All right, so this is so remember, like I mentioned here, after you do the transformation, make sure you have this, you have this, the domains here. Don't forget to transfer the domain. Okay, so let's take a look at our second part here. Okay, so the second part here, this is when the x is uniform, negative pi over 2 over pi over 2. So the first thing is here, we need to write it down, the PDFs here, right? So the PDF for uniform will be what? PDF for the uniform. So remember, like, this is the kind of we learned here, this is kind of like the formulas here. So if x is uniform, so if x is a uniform between a and b, then the PDF f of x is equal to the 1 over b minus a, right? So because then you integrate, it will become 1 here. Okay, so for here, because the x is uniform from negative pi over 2 to pi, so I know f of x will be equal to what? It will be equal to the pi over 2 minus negative pi over 2. Just like how do we define the uniform? So this will be 1 over pi here. Okay, so this will be 1 over pi. Then we will do the same things here. So y equal to the tangent x. So now I change the x. So the x will be what? Arctangent y, right? Then take the derivative. So dx dy, it will be, I know the arctangent is 1 over 1 plus x squared. So here is 1 plus y squared, right? So it's 1 over 1 plus y squared here. Okay, so now in here I can just substitute. So now I know the gy's here. Okay, so the gy's here will just be, because here is a constant. So here, this is a constant again. So it will just be 1 over pi. I'm sorry here. So it will just be 1 over pi, and the absolute value, this is my w primes, right? W prime y, and these are all positive, so the absolute value doesn't matter. So this is 1 over 1 plus y squared. Okay, so this is the PDF for y here. Remember, we always need to find the range, the new intervals, right? The new domain for the y's here. Okay, so now I know y is equal to the tangent x. So when the x is equal to the negative pi over 2, my y going to be negative infinities, right? Because I know my tangent is go like this, correct? All right, so when the x is equal to pi over 2, what is my here? So this is infinity. So don't forget, we need to write here y is negative infinity to the positive infinity. Like I mentioned, we have to do that. Okay, so in here, I want to, in a while ago, I mentioned you can do from the CDF points, right? So you can do by doing the CDF points, and so the same way you can do that, and you can get the answer. So, but here, because both of it are pretty easy to do the transformation, so I think that's that's good. All right, so That's it for these two problems here. So remember, right? So the key things you have to redo the range, not the range, the interval, the domain of the y after you do the transformation. Like I say, it's a very similar concept like the U sub in the calculus winner. All right, that's it. And let's see what we are going to work on next ones here. Okay, nice talk to you. Enjoy it. Bye.